like with such a long time, why is there no update or what was happening? So developing something fast is very important, especially if you're doing startups, right? So let's say you want to do a larger distribution or you want to improve your scale. Traditionally, two decades ago, you had about a year and a half, 2 years to develop a ship new items. Now you probably have less than a quarter because you're looking at funding, you're looking at certain stakeholders. They will push you to develop something or quick quarterly results rather than annual results. So that is always going to be a constraint. Then comes cost, right? Who wants to pay more? Right? Nobody wants to pay more. Whatever you ask, then can I do it in half? Can I do it in 1/4? Can I do it 1/10? And so on. Yes. Yep, sorry. Okay. So we were at cost constraint. So you're always constantly asking, right? Can I get this cheaper? Can I get this cheaper? Can I get this cheaper? Let's say you have, let's say, your Samsung Galaxy phone. Next year, if you want to upgrade, would you pay the same amount or more amount? No, you would want to pay cheaper, right? You would want the same features or more features, but you would want it cheaper. So you will always end up doing something which is going to be cost conscious, right? Unless you're building a rocket. I mean, even when you build a rocket, they'll be, can you do it in a lower budget? That's always going to be there. Then comes the performance constraint, right? Let's take the classic case of GPU, right? Everybody knows like NVIDIA GPUs or something, right? So every year they will end up boosting the performance. And let's say this year, next year's beginner model will be better than the last year's top end model. And that's a performance constraint. Like how many, how complex can your processor be? How can you make it even smaller? How can you make it in a lesser heat dissipation? Whatever your performance constraints are, so you'll always end up doing performance constraints. So what we did was in that particular episode, and of course you can go back to our websites, LinkedIn, YouTube, wherever, and go through those videos. They're all on record and available for you guys to see and take notes. We discussed about a framework called House of Quality. So House of Quality is a framework that allows you to put down performances and certain criterias, and then you can link them to different items. Let's say if performances get related to material, let's say for example you want a very high energy output GPU, but you want to cool it fast, then maybe you have to choose the right materials for cooling, like copper or something, right? Or a vapor cooling chamber. So linking different features or performance items to different metrics, designs, or let's say materials is a framework there's a very useful range, time and cost. So these are something. Then there are peripheral constraints, like for example resources, right? You have only a team of 10 members, but you still need to build a spaceship. How will you do it? So what about resource constraints? Then let's say you have maybe interpolitical constraints, shipping constraints, the ones that you cannot control, right? If you tried to develop something during COVID, it was very hard. You couldn't get shipments in from different countries. You couldn't get components at your ease. I remember there was a time a couple of years ago where chipsets like Raspberry Pi or any other ICs had a proper 20-30 week lead time because suppliers were running out of stock. So those are constraints that come in sometimes. Right now we have a lot of constraint getting in components from China, or let's say certain countries where there is a little bit of difficulty in purchasing components from. So those are also some of the constraints that you may end up with. But mainly these are the three categories, and there are a lot of frameworks that you can use to address these constraints. Then the third episode was prototype. It was basically scalability and adaptability. In scalability and adaptability, so basically the first two episodes you understand what you want from the product, what you want the customer to do, who the customer is, and what they need to do. But then once you understand that, how do you put down constraints? How do you build a team? How do you build the skill sets required to develop it? Once you're done with that, you probably have a prototype, maybe 1, 5, 10, 100, whatever your prototype or product looks like. You have something that you can test around. From there, how do you get from that one prototype to scale, right? You want to, maybe your product sells at like, let's say 100 million units a year or even 1000 units a year. Something is at scale, right? So doing one versus doing it for 1000 is not the same. You cannot have the same design or the same architecture or the same data pipeline or the same materials or processes chosen for one versus let's say 100 million, or let's say even 100,000, right? It's a smaller volume, but still there's a lot of things that change. So we came across what is prototype and what is market ready, right? Let's say, you've even built something for scale. Let's say you deploy a machine that is here, and you deploy a machine that is, let's say, 1,000 kilometers away. Somebody complains, you cannot travel there and physically check, right? We're all hardware guys, and if a complaint occurs, you cannot really travel there. So how do you build for scale when you have to debug a machine that is nowhere in your reach, right? How do you get enough points to debug? How do you ensure that the communication is clear? How can you do a remote reset? Can you do a remote reboot? Can you upload firmware remotely? How do you build for scale is also another thing that we discussed. Then comes DFM. DFM is design for manufacturing. In design for manufacturing, we discussed what are the DFM principles. What do you need to do? So there were things like reducing the part count, using standard components, ensuring that you are using standard practices, right? So if I want a person to do a wiring for the product, I cannot just say, okay, put this here, put this here, put this here. That people may not really understand. They switch a wire, the thing goes boom. We cannot do that. We need to follow certain standards for wiring. There are ISO standards, ASTM standards, ASME standards. So there are a lot of standards that you need to follow so that your design is at a universal language that can be translated, where your code is at an universal language, where your wiring, where your let's say drawings, all are at a universal standard. So we understood the design, DFM principles. Then we went through an entire DFM blueprint where we had some physical parts where we saw what is the, how does a part look before DFM happens and what does a part look after DFM happens. So that essentially means that if you make it, DFM in essence is if you make it easier for a manufacturer to manufacture, the costs will come down. The more you make it difficult, which means that if you're using a part that nobody has seen before, then becomes difficult because they don't really know how that works. If you're using a assembly mechanism or a packaging mechanism or anything basic that, or even a transportation mechanism that people have not seen before, then it becomes challenging and it becomes costlier. That adds challenge to your scale. So the entire DFM blueprint was about understanding what are the common practices that get your costs down. So this is basically a no-brainer to just go ahead and do it, but this is supposed to be the last activity that you do before scaling up. Because once you do a DFM, usually you don't get the chance to go back and prototype again. You don't get the chance to go back and do a market research again. So the order is kind of also important, because unless you do a proper market research, you don't know what your prototype needs. Unless you do a proper prototype, you don't know whether your customer really needs it or not. And then once you do your DFM, there's hardly a chance to go back because you've invested time, money, resources. You've invested a lot of effort into getting to this stage. So once you do your DFM, you won't get a chance to go back and say, hey, I am ready to scrap the whole thing and go back. Unless there's a lot of depth in finance, you really don't have the chance to go back. So if you follow these processes, you have multiple options to loop back and change. Once you do a computer analysis, you can again go back to research and say, customer research, and say, hey, I really don't need this. I really don't want to compete in this segment. Can I go do something else? Right? You always have for each step you have an option to always go back and check. But once you proceed from each phase, it's best to not relook into it if you want to achieve speed and time. Otherwise, if there is, let's say, if there is an option of unlimited money, you can always go back. But that's not a real world case. So this was a quick recap of what happened in the previous episodes. Today's episode is mainly around product teardown, and what we're looking at doing in product teardown is it's a way more engaging session where all of us get involved, open up certain products, and cross question each other as in, hey, what is this? Why is this selected? Why was it designed like this? Why couldn't you do it like this? What is the reason behind such a principle, or why can they not just add this into that, whatever, right? So it depends on whatever products we unbox and open and unravel. Feel free to engage in a lot of cross questions today. We are here to support you in your journey to be a founder. Being in founder mode is to get your hands dirty, ask as many questions as possible, get to the bottom of each and everything. Even if you feel that, hey, why is this screw turned clockwise and not anti-clockwise? That's a very valid question, because you being in a founder mode need to know that detail. If you need to sell a product, if you need to build a product, you need to know that detail. So feel free to get into it and feel free to ask around. It's a very it needs to be a very engaging session for everybody over here. Okay. So yeah, thank you guys for coming. So we will be starting the session quickly. So,
click. Yeah. Oh, can you? Fine. So good. You should on turn it on. Yeah, it's connected. No, I'll say.
ಇನ್ಪುಟ್ ಅಲ್ಲಿ ಬರಬೇಕು. ಹಾಂ ಬೇರೆ ಏನಾದರೂ
No, this is enough. For them, we'll slowly start. I'll finish the basics. Hey, hi everyone. So before starting, let's just want to see how familiar you guys are with the electronics. I also want to gauge the levels. So is there any students? Okay. Like any professions like who are into design embedded electronics? Okay. And has anyone worked with embedded Linux before? Okay, so okay. So if I make any mistakes, make sure please correct me. Okay. Okay. So today we are going to do a product breakdown. So it's going to start from understanding how the product was built, as Purvendra was explaining what all the recap we had so far, and we'll be following the same process and try to understand how this product was built from scratch. So that's the whole goal, and also we'll see what is the processor it is, what they are using, and why did they choose that particular processor, and also we'll try to understand the electronics that goes into this particular mechanism. So before that, yeah. So I just want to give a very small reintroduction. So I hope if any of you was not attending the previous session, so I just want to introduce myself. So myself Srinivasan. So what I am trying to build is an open source community for hardware, and we are building different modules and something that's very similar to Arduino, Adafruit. That is our goal. So whatever we build, everything is open source, and you can download the Gerber or even the schematic from the our GitHub repo. And let me give a recap on the electronics part. So last two sessions, we had a quick recap on design optimization and how to choose a component and what to do with the components. And this, So this was the first session that we went through, where it was mostly about part selection, design optimization, and about cost saving using panelization. And we had how to automate things so you don't get actively involved and optimize your production. So it's like you start your production and you should not worry about it, and you focus more on the business part. And finally, the manufacturer, like we were talking about line circuit, how to place the order on the line circuit platform, start from the Gerber, uploading BOM, and how to automate everything. And for that, we already have a website, and that's a QR. So there something we have an articles page. So there you'll find different articles explaining about different manufacturers and how it is like basically comparing between each other. And also we have all the design optimization and whatever we spoke in the previous sessions, right? So all those are given as an article. So if you'd like to read, you can just take a snap of this and you can continue reading the previous sessions. And the next session was more about how to scale your product from 100 to 1000 to 10,000 to 100K to 1 million. Sorry? Okay, okay. Not the slide, it will take you to the article page. There it is, we have many articles. So most of the articles will be related to whatever we have done in the session. But if you want, you can just go to the Line Circuit YouTube channel. So there we have all the sessions previously recorded. So that one also you can view. So yeah, I was telling about scaling the product. So there mostly we are focusing on how to design. If you're designing something for 100 units, probably you can just put some development board, put a random box, and you might be able to sell it as a pilot test run. But again, when it goes to 1K, what all the design optimizations you have to do? For example, instead of using anything as a module, you have to put all the discrete components and try to build very compact PCB, all those things. And when you are moving towards 10K and 100K, we were discussing more about how you put more engineering efforts and less of a manufacturing effort. Best example would be, I think you guys would have heard about ESP32, right? So in initial cases, it's okay to use that metal cap. But again, when you're hitting a very high volume, it would be much cheaper for you to build using just the IC and put more engineering effort into the antenna itself. So that way the cost will be comparatively cheaper when you're going to scale of 100K to 1 million. So that was just one example, but we spoke more about how do you deal with 100K in terms of logistics, how do you deal with in terms of warehousing, how do you talk to the distributor, find components, all those details was going on. So this was the products that I was just giving an example, like 100 units, you can see everything was a module. So this is I2C module, we just put the module not using that IC. Same thing for, this is a ESP32 board, the ESP32 just sits on top of that. And then we had this board explaining if you are scaling for like 1K to 5K. So these are glyph board, the development boards I was talking about. So here we use the ESP32 module directly and we build other optimized circuit to make it comparatively cheaper to the previous one. And this is like just an example for logistics. So whatever the box, it just contains 50 unit, but each product is very huge. So that will be a very huge warehousing problem. That is just contain 10 boxes. Now imagine if you want to just produce 10K units of those, you need to think about logistics, you need to think about warehousing, and you need to think about security, and there are so many other aspects. So that's the recap so far. And if you want more details, you can just go back and watch the YouTube videos and you'll have more details. And now we want to talk about the product complexity. So all the previous sessions, we focused on very simple products. Nothing, we were never trying to push it to a higher end. So I just want to give you what we mean by a product complexity. Let's take a AC or a air cooler. So it's a very simple product. It has just a compressor and it has electronics, but it's not very too complicated. Most of the electronics we can manufacture here itself. What it does is, it has a sensor which will sense around the room temperature and it will try to balance this thing. So whatever the code you are writing or whatever the optimization you are doing, it's going to be very simple. Whatever the cost that is going to cost you would be more towards the enclosure, the compressor itself, and like logistics I was talking about. Now this is something I'm telling as a simple product just because of the electronics, not because of the product as a whole, because it has more other aspects that we are not talking here. So the other complex product that we can talk is IP camera. Here you can see the product itself is very small, but the complexity is involved in this is enormous because of all the feature it provides. One is it has a camera, then it has a voice call interface, then it has a NPU inside to process AI tracking and also like auto wake up, all those things are there when there's a human presence. And then on top of that, it has some motorized control for the camera. So the reason it becomes very complex is because the amount of code that you are going to push into this. The electronic itself is going to be simple, but in terms of embedded engineering and embedded Linux that you're going to put inside, it's going to make things very complicated. Because like the other things, whatever we were talking about, right? We used to just use a microcontroller directly, not a microprocessor. So I just want to quickly dive into that difference. So I studied from a VTU based college. So I just by heart I know that's 12-mark question for MCU versus MPU. So here MCU comes under you have the flash, RAM, some of the peripherals, everything is interfaced within a single chip. So ESP32 or Atmega and other processors from microchip. Whereas when it comes to MPU, like microprocessors, let's say we are from NXP, we are from TI, we are from say even Intel, AMD, all those are processors. Now the problem with them are you can't just use the IC directly. You need a DRAM, you need flash memory or eMMC or in some cases a SATA drive. So all these additional peripherals are needed. Even just to even blink a LED, it's going to be like 10 times harder to do it in a microcontroller. So that is why most of the people just prefer using a Raspberry Pi. Whenever there is a image processing, it's very easy to get and out of the box. You run the blink LED, it just runs out of the box. But in real world application, you can't use Raspberry Pi because it's going to be very expensive, each module. And also it is not optimized for the application. Whereas Raspberry Pi initially was built only to showcase people how the computer works, and it's like a general purpose computer. It was not very specific to an application. And now in this MPU and MPU, the other difference, the major difference is the way you code. So here we use something called as free autos, and then we have something called bare metal. So bare metal is something you use register level to code your registers and control the microcontroller, which will be more efficient. But if you want to scale it, we usually use like autos. So autos is nothing but a real-time operating system, and there are a couple of versions, something called NetX, then we have Zephyr, then we have FreeRTOS. So in terms of Linux, I think you would have heard about Windows, Mac OS, then Linux. So Linux is going to make things a little bit easier because if you're not into hardware, you can just directly deploy some applications which you would write in your regular application, general purpose PC. So that is one big advantage which has in Linux. Whereas in RTOS, as I told, you need to understand each level of the register and set the register, do certain things to make it work. So in terms of development, like in a long run, the Linux is going to be little easier to develop because the applications is much easier to write, and you'll find people who can write the applications for it. Whereas in RTOS, you need to find an embedded engineer who understands the microcontroller, and then he has to code the controller as whatever your requirement is. So that's the major difference between a microcontroller and an MPU. So I have an example for that. So this is one of the SoC. You can consider anything. Currently it's from a TI chip, but you can see for a TI chip, you need a DRAM, then you have a eMMC, then again additional Wi-Fi and Bluetooth, and this is a PMIC. So this is what powers the SoC. Because just like other microcontrollers, you can't just give one voltage and you can expect the SoC to work. There are multiple voltage levels that has to go to the SoC to make it working. So this is just a gist of it. But now when you compare this to the ESP32, you can see how small the ESP32 is and how all these features are crammed into a single chip. But again, it comes with all the trade-off of having very less RAM, less memory, and also running Linux is very difficult in it.
So does it fall under micro MPU?
Which one? This is a MPU. This is the MPU that is called as SoC. And then for the MPU, you need other additional peripherals to make it run. If it is a microcontroller, all you need is just one particular IC that will have everything inbuilt. So that's the major difference. Yeah, first I thought I'll, yeah. Yeah, sure.
Can we also add new module inside the like chiplet?
Here?
Yeah, can we
No, module inside this.
like outside the circuit?
Like you can add any other peripherals, like how you would add any other displays, right? For a microcontroller, you can add a display, you can add a audio codec or a speaker, mic, whatever you want to add. The same thing you can add, but again, it will be depending on the processor itself, whether they allow and they have those GPIO pins broken out, so you can connect all those things.
And like for heat dispensation, what should be the like step if we take like for CPU to be?
Heat dissipation. Again, it depends on again how big or how intense your processing is going to be. So usually there are two types of heat dissipation method. One is called active cooling, one more is called passive cooling. So this you'll see in regular day PCs as well. So there is something called AIO, and one more is like passive cooling where they just put a large heat sink, and there's a third one that is your water cooling system. Whereas for this kind of smaller PCs, yeah. So here you can see this is one of SBC. Here they are using a passive cooling system. So this just has a heat sink on it. So this is one of the way to cool it down. But again, there is a option in this where we can plug in a fan. So that becomes active cooling. So you plug that in and then you put a fan on top of the heat sink, and that is going to dissipate more heat much faster. So heat, I think the major problem the heat will give you is thermal throttling. Basically, the more heat, the performance will reduce.
Because in like I was reading about PS5 now they are using liquid metal to
Yeah.
basically as if what is it? Because generally we use like thermal paste
Yeah,
to,
yeah.
get the
So
temperature at the level.
yeah, so that is gallium. So liquid metal, what they are using is a gallium. So what it does is it has a much better heat dissipation property. Unlike thermal paste has certain level of heat dissipation. So it is better than directly using the what is this heat sink on top of the IC thermal paste. Again, but using metal, liquid metal is way better than using a thermal paste. But that will give you a more new challenge. Where if you have seen that it PS5, right? They have a block which will be preventing it from overflowing to the other parts. So again, the complexity will increase. Again, it depends on how complex your system is and what you are planning to do. So based on that, you can decide what type of cooling you need. Yeah.
Is there any difference between the PMIC used in this kind of setup or I'm using an MCU?
So PMIC, usually what happens is whenever you buy a SoC, let's say from TI, they itself will recommend you a particular PMIC. Or if you want to design your own, that's a risky case, but still you can design on your own. So in the SoC doc, they'll give you how much is the power requirement and what are the different voltage and what are the different current rating that each particular voltage needs to have. So you can put multiple buck converters, boost converters and try to power it by yourself, but that will be more expensive. So that is why usually what the chip makers will do is they'll launch a PMIC along with the SoC. So this particular SoC, you can see it's a TPS series. It was specifically made for this particular SoC. Now if you go to NXP, the NXP will have their own SoC. Same way Rockchip will have their own SoC, something like that.
And for microcontroller?
Microcontroller, it's very simple and straightforward. It's only one voltage. So you can use any kind of buck boost converter or like direct LDO to power it. Any other questions? Okay. So I think we'll just get into product breakdown and see how this particular product was built. You want to distribute? We'll start along with this.
So I have one question.
Yeah, sure.
So in that controller, you said like in microcontroller we push the code. Okay, we have USB type of code. But here, how we push the code because there are so many components.
So that is where this becomes very complex. So that is where the embedded Linux comes into part. Even without embedded Linux, you can still code this same way how you do bare metal programming. But again, for each of the platforms, they'll have something called as a tool chain. So NXP will give their own tool chain to program this. Same way TI will give a own tool chain to program this. But again, to make it very simple, what usually people prefer is try to use embedded Linux because that's a one platform which you can put on multiple SoC. But again, you have to do some setup for it to work on different ICs. So once you get the Linux up and running in this, how would you program any regular PC, right? Any C application, Python application, everything would run out of the box.
Before we build this component,
Yeah.
we have to build the tool set first.
Yeah. So usually, what for this case, what we do is, as soon as you buy this, first thing you buy is a EVK kit. So it's called as evaluation kit. So they'll put all the SOC and all the peripherals that the SOC supports, and also all the code that is necessary for the SOC to run. So whenever you're building a product, EVK will be the base, and from the EVK you'll derive or change certain parts and then build your product. So that way it will be much faster to the market. But in certain cases, if you want to really optimize, then you have to put a lot of effort in terms of that code integration, customizing your Linux, all those will take place.
So I think we have 4 units over here. We can.
Yeah.
So today we wanted to make it a bit different. We have given cameras to you. You can make maybe groups of 4, and we'll do the teardown of the
Yeah.
product together. So while streamers does it, we always have this, right? Like we watch these videos where people break the phone, open it up. So we'll do it more, in a more sane way. We'll use screwdrivers, we'll open the boards.
Yeah.
We'll see, like, we wanted like all of you to try actually open a product and see what is inside. So
You guys can split up into 4 groups. There are tools over here. You can come and start the journey.
That smaller table was there, no? We can put that smaller table. A brown table itala. I had brown table alla time. They can sit there. I think it is.
we'll put some maybe 4 tables.
2 brown tables. That brown tables are there. You want to open?
You get one table here, no?
Yeah.
You get one table here and
No, there are 2 tables, right?
We'll put the table.
Yeah. Alle. Speaker இருந்துச்சு.
Please talk for this.
No. I'll just guide so you guys can start. Huh? No. I'll tell you where to unscrew everything. We have the process here also. I'll show you the setup. You guys can sit if you want. Put it back and get the chairs here. Yeah. Right. You need to just remove the sticker and we can.
good way to
Yeah.
avoid.
Yeah, only 4 sets.
There's only 4. You can make a group and participate. That table is also empty.
So we have a camera, but we don't have a set.
There's only one. That's it. That's the only product, right?
Yeah. Okay, so we're just looking for a set.
If you want, you can join here as well. This is also a set. I mean, I'm showing here. If you want to join, you can join here as well. I'll show the opening process.
So we do have a camera. We just needed a tool set. This is what you're looking for.
Oh, you just need a screwdriver. They're looking for a screwdriver.
I built PCB. I ordered from here only.
Okay,
Actually.
okay.
So initially I went like I become an entrepreneur in the between. But problem was that when I was doing this, I'm a software engineer. The components, no, I cannot source it.
Yeah.
Even
So
though I built the PCB,
Yeah,
okay. But and I was using hand solder, okay.
Yeah.
So I wanted to do the CMT thing.
Yeah.
But the component, I don't know how do I.
No, currently we have it on the platform
DGKey
itself.
and everything, no, DGKey.
Yeah.
That requires a bulk order. And
No,
a lot of,
you can order one part even from DigiKey, and also there's a Lion Circuit website.
Okay.
Lion Circuit/parts.
But if I order from you, you will manage the components.
Yeah. You can even order one piece. There is no quantity
One
limit.
piece is the PCB, is it?
No, one piece.
Or
The component
with
also.
everything.
Everything. SMT,
But
like
then
soldering
it
and
will be
everything.
expensive, no?
Again, it depends. I can't tell whether it will be. It depends on the complexity of the PCB and the component that goes into it.
Oh, with the components also I can order.
Yeah. Components,
But that
assembly,
will be
and
hand soldered, I guess.
no SMT soldering. Like
Oh, you do SMT solder for one piece also?
yeah, one piece also can.
So, okay, I will try because
Yeah.
I have perfected a little bit.
Okay. No,
Now I
because
think-
this is not possible to do in
No, this
SMT.
is not possible, but
Yeah.
simple audio
Yeah.
circuit.
Because these are called
These
as a
are
BGA.
expensive, yeah, I
These
know.
are BGA components. Even soldering is very difficult.
No, I am basically into the audio side actually, audio PCB. So in the beginning, I was building from bringing from China.
Okay.
You know this one James PCB.
Yeah.
So it was falling becoming very expensive for me. Then I found some land.
Okay.
There is one in this Jigni. There is one circuit making company there, but that required a bulk order.
Okay.
That company. But luckily you had
Yeah.
10 or 20
Yeah.
clients like that.
I think the best person would be you can talk with Murli, or I can connect you with somebody from the sales. They'll help you how to register, how to get components, everything done.
The component part and I need to
This Rahul, right? So he's the one who's handling sales. So he can help you with that whole process.
I will take a card from
Yeah, you can take his card. No. Yeah, but everybody started. I don't have the screwdriver. No, I thought it will be very easy to show from here.
Ask them to hold on.
Okay. No, ಅದಕ್ಕೆ screwdriver ಬೇಕು. Screwdriver ಇಲ್ಲ.
We have.
Sorry?
This is designed here.
Yeah, I guess. I should ask them. Huh? Line circuit. You need to ask in line circuit.
We have screwdriver.
No, somebody took from here. Somebody took from here.
Check in this one.
Guys, I can take this? No. No, that is why we did not get the.
No, we did not have.
Okay. Yeah, got us. We can give it to them. Yeah. No, I can. Guys, it'll be good if you can sit, so I can show you the full process. It'll be much easier. You can get a chair here. If you want to sit here. No.
We use that once. 2 screws are remaining.
Yeah, here, right? This is one.
Yeah.
So that will open the whole thing. Yeah, you can just pull it open. That's it. And you remove all this.
Got it. Let's
Yeah.
wait.
Then this one.
Yeah, sure, we'll remove.
That's it.
So the amount of data that can be there in a microcontroller, the programming, that should be way less, right, compared to a
Yeah.
SoC, right?
Yeah.
So if everybody can just come smaller groups, Srinivas will show one demo and then we could all do.
Yeah.
Yeah.
And also I can explain you how the things. Yeah.
So quickly, let's all just settle down in groups and we can continue. Okay, guys in the back, can you go in?
Sir? Yeah. Yeah. Okay, guys. I'll just go ahead with this. So I think most of you are already done, but it's very simple. You just remove the sticker from the bottom, and you just remove that first screw. Then we'll start with the bottom PCB. So I think many of you might have ignored that. So in the bottom, there is a particular PCB. So if you can see, that PCB is here. Yeah. So this is the bottom part. So it has three major components here. One is the Ethernet, and one more is called the magnetics, and one more is the power. So power, basically you power it, the entire circuit using the USB cable, and it will there is no battery involved in this. So it's going to be like a 5-volt DC supply that is going to power the entire circuit. Then next is the Ethernet. So Ethernet is where you connect your LAN cable and you give the internet connectivity. And finally, the magnetics is something that is to do with the Ethernet. So in the Ethernet protocol, there need to be a magnetics which will convert the higher voltage to the voltage that the IC can handle. So usually Ethernet will carry like around above 40 plus volts. So to convert that, we have like this is basically a transformer which is put into a IC package. Now this is where we need to really appreciate these guys who have designed this, right? Because usually the Ethernet itself is very expensive component. Here if you see, they have used a plastic, and it is just a connector and it does not have any electronics inside it. And then they have put a magnetics separately here, and then they have made this connection. So usually if you see boards like a Raspberry Pi, there they'll have a magnetics with the connector itself. So that will be a metal enclosure which will have the two LEDs and everything. So this is one of the cost optimization method they have used, where they put a cheaper plastic one and then have a magnetics externally. And then the Ethernet data, right? So that is carried through this particular cable, and which is in turn connected here. So this will carry both power as well as the Ethernet. And now on the top we have a stepper motor. So this is called a unipolar stepper. Yeah.
Connector has only 4 pins also.
Sorry?
Not only they put plastic, but it only has 4 pins.
Yeah. So they try to like maximize the cost as minimize as much as possible. So usually Ethernet has like Again, it depends on the speed as well. So there is something called base 10, base 100, and gigabit. So this is, I think it's base 10 or even base 100. So again, even though connectors are here, it again really depends on the SoC itself, at what speed it communicates. So if the SoC lock itself to 10 base, then there is no point of having many connectors. So anybody have that guitar pick or something to open this? Yeah. So I was talking about this particular stepper motor. This is a stepper motor, which is a unipolar stepper motor, and this is actually a very cheap one. So there are two types of stepper motors. One is called bipolar, and one more is unipolar. The accuracy is not very poor, but moderately poor in this.
It has a gear train inside.
Yeah, it does.
Along with that.
Yeah.
Generally, steppers are only like one
Yeah,
single
that is
star.
the bipolar ones. So in that bipolar ones are the ones that is used in like 3D printers or like any industrial automation, because they have very high accuracy, and also they are very fast. Now let me strip down this little more. So that's the first stepper motor. So basically having two stepper motor will give you two direction. Yeah, basically it can rotate in one direction and also another tilt up and Y in Y axis. And one more thing, I'm not sure if you have noticed, all the screw sizes will be the same. Yeah, again that's because of the cost, and also it will save time in terms of assembly. So that comes into repairability as well, but again nobody really repairs all this, they just get a new one. So when you remove, again it will turn into two parts, one with the speaker and one more with the main PCB itself. I'll just remove this. Yeah. So this is the final PCB. It's a single PCB, and this is how again they save the cost. There is no additional say PCB or modules except for this Wi-Fi module. I'll just quickly show here. Yeah. So this is a back view, and this is a front view where the camera is here. And here they have another notch here. That notch is for microphone, and on the top there's another notch that is your LED. And here we have again 4 different main ICs, and rest are very simple passives. So the main one is this one. It's called Sigma Star. Have you anyone heard before Sigma Star? So Sigma Star is another SoC manufacturer. Again, it's based on China, and they completely focus on IP cameras, and also like mostly into like video streaming devices. That is their main this thing. And many of the SoCs or many of the devices, right, which deals with camera, you can see their SoC from dashboard, dash camera, or IP cameras, or video doorbells, and so many other applications. Now again, that's very difficult to answer. I think it might be like some $4 or less than that. Even might be $3.
Manufacturing that is not there in India.
No, nobody, not in India at least. So
Still does not have the capacity to manufacture.
there's only one company in India who is actually doing it. It's called Mind Group. They are the one who is building a SoC called Vision SoC. But again, it's just a concept for now. Even though they have like very good funding. Yeah. That's the only company who is designing the SoC for camera. So there are no other manufacturer. Mind Group. They are based on IIT Madras. But again, it's just a.
That is the whole brain of the whole thing.
Yeah. But again, it's just a concept. They're still working on it. There is no timeline when they'll release or what is the process, nothing so far.
The recent semiconductor plants that government has announced, 6 factories, etc. There, once it is designed in IIT Madras, can they manufacture there?
You mean in China or
India.
India manufacturing? Again, it's going to take a lot of time. It's not going to be very easy because one, I think many people miss is we lack a skill gap more than money. Yeah, so that is going to hit very hard. So until we fill that gap, even though they are pouring in billions, it's going to take a lot of time.
Even if you have the SoC.
Sorry?
CDAX Vega processor.
I'm not aware of it. Like,
That's
So-
not a view. It's a
accelerator.
this 5 this calculator.
Okay.
Good.
Okay. It's a microcontroller. Yeah.
What about the whole product? Does Indian have the capability to manufacture such a kind of device?
Yeah. Like we can manufacture. Yeah, we can manufacture the scale. That's not a problem.
What about plastic?
Yeah, plastic is also possible. Yeah, but
Quality.
same quality is a question. But quality is fine, but you can't match the price for the plastics.
Whole ecosystem is required. Now these all connectors and everything is not
Yeah, like
available.
again, there are people manufacturing in other countries as well. They're doing it on their own. But again, unfortunately, we have to still rely on China to get that parts. There is no other option.
All these CCTV cameras that goes into defense and all of those.
Yeah.
Again, all things are from China.
No, they would be ready to pay to other bigger companies like NXP. I was talking, right? TI and NXPs.
They go with what?
No. Bosch doesn't make their own SoC.
Not SoC, cameras.
Cameras, I don't think so. They make modules. They take cameras from other vendors like Sony and Samsung. Yeah.
Sensors are always branded, no? Sony and others.
No. Like whatever is in this, like completely unknown brand. Again, it's a rip-off. Nobody knows what sensor they are using. So even we tried finding what it is, but we are not able to trace back. I'll show you later, like images we have taken from some microscope.
So the main question here is what is the entry to barrier that India is currently facing in terms of designing all of these things?
The biggest is the skill gap again. It's very
Specifically in what terms?
like the whole hardware ecosystem, architecture as well.
Architecture,
Yeah,
VLSI.
yeah. No. VLSI mostly into like deciding. Yeah.
SMT machine also comes from China. I don't think it is not manufactured in India.
One question at a time. It's like overloading. So I'll just finish that. So you were asking about the skill gap. One is the major skill gap. What I mean by skill gap is not just in terms of VLSI or in terms of PCB design or something. It's more like you need to know where to pull in the resources, put together to build a hardware device like this. So you need to have like, but again, you'll get only this once you start deep diving, start working for other companies. That is why you see most of the semiconductor industry or any hardware manufacturing, they'll have a background working for bigger companies like Apple, Samsung. So they need to have that background to understand all this so they can put together. But the advantage is there are solutions like take line circuit as a EMS. So they can have all the resources inside. So you can just come talk to them and try to figure out all the processes at least. Then from there you can take it out, like whether you want to design it, they want to design it, where do you want to manufacture, all this. Again, they are a distributor. Arrow, Digi-Key, Mouser, they are just distributors for components. They don't produce anything on their own.
Designing somewhat India is now picking up.
Yeah.
I think these kind of single board money computers are being manufactured here. So we are getting manufactured one of the boards.
Yeah. I think you guys would have heard of Vicharak. No? Vicharak. Yeah, Vicharak is one of they are making more FPGA and rock chip based single board computer, which is extremely good, and they are giving all the technical support. And also the good part is they've been funded like $2 million plus very recently they raised, and they've been doing very good. And also I've been like following up very closely what they are doing, because my job is to make open source devices, and they are very close in line with whatever I'm doing. So I'm following up with them, and they currently I think launching a new FPGA also, like a very small scale FPGA. Yeah, the name of the company is Vicharak. Yeah. Surat. Yeah.
I think they have 3 products.
Yeah.
Have you seen their SDKs for the rock chip? Because like there's another Pune-based company who is doing a rock chip-based alternative for Raspberry Pi.
Yeah.
And
There are a lot of
main problem was SDK support and essentially quote-unquote.
So I'm really not sure how they are doing it, because like I haven't directly been in touch with them, but I do follow their GitHub repo. I can see them directly making all the patches for Linux kernel, and they're also putting a lot of effort into mainlining their board. But I'm not sure how they are pulling the resources for that. It could be because like they are getting expertise around the world. That could be a reason how they are pushing it. So if you know in and out of Linux, I mean it's a long shot, but I think you should be able to do at least bare minimum using just the data sheet, even though there is no SDK.
I think the problem is on the Linux side of things. It's on the hardware that you are implementing and designing. It's writing kernels and hardware specific code onto Linux for that.
That's what I was saying. Device driver is a problem. No, what I meant was Linux is you need to make it work right. So that is going to be very difficult. So you can't just randomly, without help of a manufacturer, you can't put a Linux into a SoC. But you would have seen there are people who actually did it. Like there are people who put Linux into ESP32. It's not like they were officially supporting it. So there are ways to still do it, but you need to know in and out of Linux and also in and out of the hardware to do that.
When we design in India, major issue is documentation as well.
Yeah.
Because we design thinking that yes, it will work.
Yeah.
But the person who is using it, he's not having any clue of how to do things.
Yeah.
So that is one more.
Documentation is also very, very important, especially the chips like Rockchip, Allwinner. They're not going to give you all the details. So they would only if you hit a volume of say 100k units. Yeah, 100k is a minimum MOQ because.
Closely working with open source, what is your documentation policy?
Yeah, I can. No.
Because that is a in general issue
Yeah.
across programming, electronics, or like it's just an issue. Engineering engineers do not want to document once they're
Whenever we
done.
have an IC, it will go for documentation. I have a document for this, regular documentation and reuse.
So this is our documentation. So we have any boards that we launch, we'll have like every single pin, what it does. We have like assembly, how the power management happens. This is, yeah, here. And we can see any other modules we launch. Say this is a new product that we launched. So everything we have like complete documentation on it, from basic setup until like how to like get it up and running. So even like if you see, there is something called Zigbee. I don't know how many of you have used before. So this one also. So usually this Zigbee thing used to cost a lot before. It used to be like 1,000 rupees or 1,500 rupees just to get the modules. And now I think the XB cost is like around 2,000 to 3,000 rupees if you're getting from like vendors like Robo or some other vendors. Whereas this board costs only 499 rupees, and it does both the Zigbee communication, and you can do it either in a Arduino IDE or even you can use the IDF platform, ESP IDF, to do the same communication. And this is not documented like publicly, but we are the one like who are pulling in all the examples from different places and putting everything in a single place and doing the documenting process. So we are more focused towards documenting, so that
I think that is
yeah.
just it, right? Like
Yeah.
if you don't really
Yeah.
have documentation,
Yeah.
nobody knows what you're building.
No, again, there are people like crazy people are there. So let's take ESP32. When they launched, there was no documentation, but still people used it because it was very cheap, and it gave Wi-Fi, internet connectivity, all those things. So again, people will try to put in effort and make it work, but documentation is very important, at least like if you want to get started. So we'll just continue. I think we got sidetracked there. Where is the... So any of you remember where we stopped? Yeah. Yeah, sure.
What was this purpose of this sheet beside the line cable?
Sorry? Oh, that is called magnetics. So it's basically a transformer, a miniature transformer put in like parallel, and they have just packaged it.
So we are already getting 5 volt from the battery.
No, we don't get through Ethernet. You won't get 5 volt. Ethernet cable is above like 40 volt, so that has to be stepped down so that your SoC can handle. So yeah, I was just talking about the main chip, and I was asking about Sigma Star, like manufacturing and all those. There are other chips apart from Sigma Star. There is a Rock chip, obviously. Then there is something called Allwinner, and especially if you want to go with the same route, building IP camera, there is from NXP also. There are very good SoCs. It's called IMX series, IMX8, IMX9. All those chips are there. But again, the price is going to be like at least 10x. From compare with this, that is going to be 10x. But again, that is what somebody asked about the defense, right? Defense would probably prefer using NXP or from TI or any big branch. They are okay with spending a lot of money, but NXP is having one of the best documentation. And one more thing from NXP, what we like is the mainline effort. So these guys, they don't push any of the code to their mainline. So they make their own fork of the Linux kernel, and they just keep making changes, so it works only with their SoC, and they don't push it back, whatever the effort they're putting. Whereas NXP, TI, all these guys are like purely working on it and also heavily contributing. Yeah. So those guys heavily contributed to open source things. So yeah, this is the Sigma Star. So you can see the part number as well. So this is the part number. If you search, initially if you search, you won't find anything. You have to put Sigma Star, and then you have to search for the SSC332. So that is a particular IC. Now let's just deep dive a little into that particular IC. I have the data sheet for that. I need to stop this. So, have you noticed anything weird about the Sigma Star IC? No, that is not the weird part. There is a weird part to this. Anything that is different from the SoCs I was explaining? Huh? Yeah, exactly. There is no external RAM, there is no external eMMC, there is no additional components. It's just a single IC. Yeah, no PMIC, as in, nothing. It's and apart from that, you can if you closely observe, it is not even BGA. So, so if you have a BGA, your product has to go through X-ray to verify if something goes wrong. There's no other way to know if the soldering is done properly or not. In this case, it's much easier to do a AOI and figure out whether something is wrong with the soldering. So that was like very crazy how they were able to find a application and then they build it. So this is where the name comes ASIC, application specific IC. So this is one of a kind, but this runs Linux. So that is the reason it's called as SoC as well. So here there's a lot of features. One is DRAM, so it's fixed only 512 MB, so you can't get any more RAM, additional RAMs. So let's say you are building a product and you start with Sigma Star. What is the first problem that you're going to face? No. That is like more technical, more in product view. Upgrading is going to be a very big deal for you. So let's say you launch your first product with this. Now, how are you going to launch a second product? It's not like you can just increase your RAM, or you can't make like multi-level products where you have a lower tier with less RAM, higher tier with more RAM. So that's going to be a lot of difficulty in this. But that is the trade-off for the cost, because this is going to be significantly cheaper because the DRAM is integrated. That is one thing. And second one, if you see, it has a connectivity. It has a Wi-Fi host controller or this communication, right? We are not able to figure out how it's communicating, but it has to be either through a USB communication protocol or through a SDIO protocol. So that is how the Wi-Fi chip, I think you can see there is a Wi-Fi chip, right? There's a box. Yeah, there's a module. That particular module is a Wi-Fi chip, and that is how it is communicating. And it has like very interesting features. So if I go to the block diagram, yeah, this is the block diagram. And you can see it has a direct MIPI camera connector, but the disadvantage again, it supports only 3 MP camera, 3 megapixel. You can't upgrade it to a higher megapixel camera. So that again you have to be aware of. And next is, you can see it is already having a GPIO pins to control the panel tilt axis. While disassembling, we saw there were 2 stepper motors, right? So that control is also inbuilt, and also it has a temperature sensor, light sensor, and again UART, SPI. They have a JTAG for debugging, and this is the DRAM, and they have a sorry, the flash is not inbuilt. There's a flash IC that is separate. I'll just show you. That is also separately they have placed it. And but apart from that, they have a ADC for doing the audio, and they have a DAC for doing the speaker output. And anything interesting? Then they have normal PLL clock, and it's an ARM-based processor. So porting the Linux to this, for them it might have been much easier. And also like architecturing in terms of VLSI is also easier for them. Just get the IP from ARM and then they build the other peripherals around it. And this is the Wi-Fi module. I think I spoke about it. And also they have a SD card. So once you remove this, I'll just show you. There is a SD card behind this. It's removed? I'll just. I think that is all. I'll take that one myself. This guy's camera. Yeah, so I think here you can see there's a SD card as well. And again, there is no additional peripherals needed for that. It's just direct lines that you connect to the SDIO, and it will run at a very high frequency. So it's called a SDMMC protocol. I'm not sure if you have used it, in even ESP32 has that. So SDMMC is much higher speed than using a SPI protocol. So that is what here it's mentioned, SDIO control is going on there. And this is one data sheet. And then we have another IC, I think ULN. I showed you 2 stepper drivers, right? To drive the stepper drivers, they have ULN. This is the ULN controller. You can see I'm showing a very branded one from Texas Instrument, but it's a funny story because you just take the same IC, you go to Texas Instrument. I think it will be better if I show you live. Let me search for that. ULN 2003 Ti. So if it actually take from TI, it is going to cost somewhere around 50 rupees, let's say, or 40 rupees. Now, if you go same thing for like a Chinese alternative, Yeah, and you can see it's going to 0.00. Yeah, so it'll be even cheaper actually. Alibaba is not even the direct vendor, so it's a random distributor who is taking from the vendor and they're giving it to us. So there are multiple clones.
Parts are cheaper there or labor is cheaper?
Sorry, no, labor is not cheap.
But now it's
Labor is very expensive right now. The reason is their ecosystem is very good, so that is why they're
Very skilled actually.
yeah. That is another big advantage. You can so recently last month I visited Ochongway. So you can find everything in a single road. You don't have to cross the road. You'll be able to build an IP camera on your own, or you want to build your Android device, you can build it in the same space. I think you guys have watched the videos also where people build iPhone from scratch. They go to different floor in the same building, they collect different components, they assemble it by themselves and they can build a phone. So that is one, and they know what the components are. If you don't know, they can help you figure it out. And also they work very closely with, I don't know, like politically, I don't know how good we have the relationship with them. But business-wise, at that particular location, it's much easier to have a conversation with them, and they'll be more than happy to help. And they'll never be like, oh, I don't know, I can't help, go find somebody else. They'll never say that. So they'll always try to get as much customer as possible. Even if it is not with them, they'll try to go find somebody else who can do it for them. Yeah.
So when these clones are there in the market, are these essentially the OEMs and the manufacturing plant directly selling them off?
That is actually, it's a very tricky question because we don't know how they're doing the clones. It can be because they understood how the processor works, they build their own IP around it, and they somehow making it cheaper because they're manufacturing it there. Second could be like some other company putting in a lot of effort. They could just take the IP somehow and they just manufacture it on their own because they're not paying for the R&D. They're just doing the final step, that is your silicon. So silicon will be cheaper. So maybe since they're not doing the R&D, the final cost is cheaper. That is another way. Or maybe even they have some direct contact with the vendor of TI, and from there they might be directly getting only the SoC and they're repackaging it and they're selling. Again,
Just a quick question on the same line.
no, I just want to clear one thing. Whatever I told so far is just hypothetical. There is no guaranteed how they are doing it for a cheaper price.
So does TI in-house manufacture them, or do they have the plant set up in like China and all these?
Yeah, they currently I think 2020, I don't know, 2029 or 2020 they started their own plant in Texas. But again, it's not a no, I'm talking about the new factory they opened up. So it just launched last year, 2024 or 2025 they launched, and they're doing it in US itself, the manufacturing. But I think that is going to be more focused on defense and higher end product because their cost of labor is very high and their cost of manufacturing is very high. So their best target customers will be like defense and medical industry and so on. But again, commercial, it's very hard to compete with these guys. So basically ULN, what it does is it just powers the stepper motor, and there's a signaling process ABCD is there. The direction how you power it, the stepper motor either will turn in clockwise or anti-clockwise, and that is how their tilt and pan axis is going on. And then we have, I was talking about the flash chip, right? So this is the flash. So this is the 64 megabyte flash memory that they are using, and this is how they are storing all their data. Like in terms of, let's say the, Linux kernel stays here, and they pull it from here and they do the processing after that. Again, the reason they need such small amount is there is nothing to, like say, highly, like they don't store anything on board because everything goes to the SD card, and all the processing happens in the RAM itself. So any application you run, the application is going to run on the DRAM. It's not going to run on the flash memory.
What size is the RAM?
This RAM 512 MB. Yeah, so this is like twice as that. So because when you take a picture, that's when you're going to generate the data, right? And that data will lie on the RAM. It is not going to come on the flash. So only the protocol to take a photo will be on the flash, and the actual photo or actual pixels is being processed in the DRAM, and then it will be pushed to SD card. So it will never come to the flash memory. So that is how they are able to save the cost here.
Flash memory same as EEPROM.
Sorry?
EEPROM flash.
No, EEPROM, again, it's like a very, very old version of flash memory. So there you stores everything in bits and bytes. It's not like you can store like a file, all those things is not possible there. And EEPROM is more preferred towards microcontroller environment where you want to store like 1 bit, 2 bit data. This flash is like to store like very large files. And then we have this. This is the particular Wi-Fi chip they are using. And again, cost is we were not able to get the cost for this. But I'm pretty sure this is going to be like way cheaper than ESP32. Because ESP32 can do a lot more things in terms of processing, in terms of clock speed, in terms of connectivity. It has Bluetooth and it has a dual core processor and so and so. In this, everything is cut off, just pure Wi-Fi access. You just connect your Wi-Fi to your SoC. But we are not able to get the price. We have to inquire and try to get whatever the pricing they have. Yeah, I think we covered all the major ICs. So these are the 4 major ICs which is there in the camera. There's nothing much. There's one SoC, one Wi-Fi, then we have a motor driver, and then we have a flash memory. Yeah. This one? No, we are not able to get more information on that. Like this one? This one? Yeah, this is ARM based. Sigma Star is ARM based. Hmm. No, I did not get your question. Like.
So that chip have a certain function, or is it like for coding? It's very specific that functionality is embedded into
Yeah.
this particular.
So it's specifically made for a camera application. Just for IP camera, they have made that particular SoC. Whereas when I was talking about NXP, TI, right, they don't much focus into that. They try to make very generic, so their IC can put into like multiple applications. But in that case, it is going to cost you very high, and here it is going to be like 1/10 of the price.
What are these two components on the right?
This one is ULN. This is your motor driver. I showed you that 2 motors, right? So this will consume very high current. So it can't be driven directly from the SoC. So there will be like a converter which sits in between and translate the power to that. And then we have the flash memory. So that is where you store all the data, where your kernel also lies into the flash memory. And camera. So this is another part. I think this is the sensor. So somebody asked, right, what sensor was going into this. So we won't know what the sensor is because there's no marking, there's nothing. It's a direct image sensor. Whatever the pixel it sees, it will be directly pushed to the SoC. So this is another way how they reduce the cost. Because when you take a module by itself, right, when you take a camera module in the Raspberry Pi, there is a PCB, then there is an image sensor, there is a lens, and there is a plastic, and the whole assembly process, and there is a ribbon cable coming out of it. So those costs will be 10 times as expensive as just the image sensor because there's so many components to that. So here what they are doing is they're just putting the what is it called, the image sensor directly onto the PCB. That is how they are reducing the cost. And on top of that, they put their custom lens and they attach to that. Now this comes into a lot of engineering efforts. It's not very easy to put a image sensor directly onto the PCB because when you turn back, there are a lot more components. So it's very hard to manufacture as well as it's very hard to design. So you need to understand how this is going to affect, and you need to run multiple simulation to understand what is going to happen to the camera sensor as well as to the other components around it. And also there's something called image tuning. So all the stuff have to be done by yourself. So the engineering effort will be significantly higher, but the final result is the cost of production will be lower. So when you are doing for say 10 million or 1 million products, this is the best way to go. You'll never use a separate module like only this module and you put a FRC cable. And this has a IR cut as well. So IR cut is nothing but a feature where you can, this IR filter, basically it will remove the IR filter, so there's a night vision. In the night it will flash a IR light and you can view it. So that is called as IR cut, and that is this connection that is going here. And these other nice optimizations they have done, what we notice in the product. One is the antenna. So again, if you see the module, right, the antenna, they're not using something like an inbuilt antenna, or they're using some patch antenna, or they're using any wire to make the antenna. Because again, wire is going to be expensive, the assembly process is going to be expensive, how they're going to mount, so all this time is going to take a lot. So what these guys have done is they put more time into the research itself. So if you see, this is the antenna, it's just a metal part, but again, this is very difficult to design, because this will be based on multiple factors about your case, the electronics, and so many other different factors. So that is how they design the antenna. And the other interesting part is you'll see a lot of DNP components here. So there'll be a lot. So they would have designed for multiple components around, for multiple fail-safe systems. But towards the end of the production, what they do is they just remove whatever is not necessary. Whichever is the best case for them, they'll try to remove as many components as possible. Again, that will increase your soldering cost if you add more components. Again, the cost of the component also will be included. Yeah. Any questions?
I have a question.
Yeah.
More on side of your boards, if I can ask.
Yeah.
So can you tell about, like, in your boards you have taken ESP32 as the
Yeah.
So how do you came down to singling out, like, you have to build your board around ESP32? What were your
So
motivations
basically, the reason we chose ESP32 is because of the one is cost and performance. Cost to performance ratio is much better in ESP32 compared to other ICs. And second was we are focusing more onto IoT and all those things. That is the only chip which can give you IoT and Bluetooth BLE connections. None of the other chips can. So that is the reason why we choose.
I think we can mention that. So he has a pipeline. I'm sorry, I'm talking.
Yeah, no, it's okay.
But so the roadmap is to use a lot of Indian semiconductors. So we are already talking to you. ESP is Chinese. Okay. So we want to have a path to go for Indian semiconductor. So for example, what I mean by that is, let's say today Srinivas is I don't know, like 20,000 boards a month or 2,000 boards a month. So once he has like 10,000 units a month, we can go to an Indian semiconductor company, help them out, because a lot of companies, when they want to launch something, it's very difficult. Like, where will they find customers? Right? There are a lot of fabless companies in India where they don't know where to sell. Right? And it's very difficult because unless you give some hardware kit, an EVM board for someone at a lower cost, they can't even get started. Right? How will they start exploring? So what he's creating is basically a platform for a lot of other semiconductor companies to come in and build the products. So, for example, he's going to be launching maybe next year one of the ICs with an Indian semiconductor company.
So India the manufacturing
Yeah, I told you just. Yeah. I told about the SOC, right? But again, it's far-fetched. It depends on when they launch.
Yeah. So there is one
No.
which we are in advanced stage. I don't think they're going to release it today, but it's a Chennai-based company, and so that's going to be like almost like what this board is, with a wireless processor and stuff like that. So that is one such application, right? Like, so eventually you want to support. See, there is a lot of Adafruits, Speech Studio, DigiKey, Moser. All these guys have their own development tools, right? So none of them will support Indian ecosystem because none of them are Indian, and none of them will. If you say, like, do a board for me, nobody will do, right? So we are trying to build that ecosystem here in India, so that like eventually we can support our own ecosystem to come up in whatever various forms, right? One is some semiconductor, microcontrollers, multi smaller things.
What would be the USP of this Indian ecosystem over? I mean, why would anybody?
I think I'll answer that. So you just a while we had this chat about China. Like, even though Chinese labor cost is very high, why they are able to produce at a lower cost? So because of two reasons. One is skill labors, and second is their ecosystem, and that is what we are trying.
Now,
So
like, coming to USP part, right?
Yeah.
So see, right now there is no. We are trying to work with them and come up with something which makes sense, like in the market, right? Like, so a lot of times what happens, so like especially even a lot of fabless semiconductors, right? They are constrained by a lot of things. So ESP, the guys who are
Elaborate fabulous.
They come stand here.
Samriddhi.
So fabless is basically like, you know,
One-
any
one
company
more.
which doesn't have
One more.
their own fab, right? Like for example, TI has their own fab, a lot of fabs, right? So Texas Instruments, and then similarly Microchip has their own fabs. So, but like if you see Micron has their own fabs, they are building in Gujarat, right? That's their own fab that they're building. So similarly, what happens right now? Building a fab is very extremely capital intensive, right? Like we all read now every day in the news that somebody is investing 5,000 crores, 6,000 crores. That is not sufficient to build a. That is not even sufficient to build a processor node. Meaning, like for example, okay, I'll break it down. So you have different types of semiconductor fabs, right? So if you want to build something, let's say, you know, let's say you want to build ULN 2003 in India, right? So ULN 2003 that he showed, you know, we all saw in this board, which is a motor driver, right? So it's basically a Darlington pair, right? It's a couple of transistors in a Darlington array. It's basically like a buffer, current buffer, right? So if you want to build this, it is relatively simple, right? Because it's a 300, 400 nanometer CMOS. You know, you're able to build transistors, and very straightforward. Comparing, it's still difficult. It's comparing to a processor, comparing to an SoC, it's still like not as difficult. So you can do that way, right? So let's say you want to build that fab will still cost you at least half a billion dollars, 4,000, 5,000 crores, million rupees is what it takes to build an IC like that. If you go to Experience today, ULN 2003 is what?
Very simple.
5 rupees, 10 rupees.
Yeah.
So now, how do you recover your investment back? Right? So this is a challenge for everyone.
But is it not a possibility to use the existing fab like
Exactly. That is the fabless one. So now you have an idea as an individual. You want to build something. You have the design tools. You have the design knowledge. Now you use already an existing fab. Build something there and take out the device. That's a fabless one. So now India has a lot of design companies who are trying to build Indian semiconductor companies, but they have to still rely on TSMC or Foundry. You know, there's one Foundry one. There's so many other Taiwan-based and Singapore-based, you know, Southeast Asian countries-based semiconductor fabs. You have to rely on them. Meaning, so they'll have cycle, right? So just like how we build PCB boards, so we have like our own production cycles, right? Like so like that, there are cycles for building the semiconductor also, right? Like once the process starts, if there is like 36 layer or 46 layer semiconductor layer fabs, it will take like 36 days, 40 days to build those wafers. So they'll have their own cycle. So you'll have to be aligned with them. So if you miss one, the next might be like 1.5 months later or 2 months later, whatever, right? So you'll have to align and you will have to have a availability to go into that particular wafer, right? So you'll have to book in advance. So there are a lot of processes to do that, right? So, but it's a good start, right? If you build semiconductor, it's a good start. Like you can use some of those things, and a lot of good successful companies are coming out in India, building fabs using outside processes in India, right? Whereas can we build like our own fab in India? We can, but it's like
I was saying, what about this SCL and others?
SCL, see, okay, now to compare this, right? Like to compare this, like ULN 2003. ULN 2003 can be manufactured in SCL, but can you manufacture SoC? No. I think right now, not as complicated, but they have done 28 nanometer they have achieved. but at a production, not at a
Scale,
production
not
scale. It's basically at a prototype scale. Right? Like meaning they can do one wafer.
No, that is
I don't know the lead time.
yeah,
maybe
that is
3
one
months or
of
something.
that is one of the reason why we are not using Tejas also. Even though the SOC it's there, we are not using it because there is no guaranteed what time we'll receive it. Like let's say our product will be out of stock for most of the time because there is a very large lead time to get the IC.
And also the main thing, you were asking about USB, right? So if you get a ESP32 for let's say 200 rupees or whatever, it starts at one, some of them are 140, some
It depends on the IC.
whatever, depending on this thing, it comes between 150 to 250 range, right? So that has a very good controller. It has Wi-Fi, Bluetooth, everything integrated.
Ethernet also.
Yeah.
Then you have another controller wherein you don't have any wireless processors. You have to put separately. Then you have only the microcontroller. Which one would you opt? Most of the applications they go for ESP32. But let's say something you want to do. You're working on a security application, right? Like so there are a lot of regulations not to use specific countries IC or something like that. Those are the areas where some of these IC can thrive right now, right? Because you'll have to show this is my design. Like I'm not using any of the Chinese ICs. I'm going to use like this is my semiconductor. This is my wireless processor from this company. You'll have to expose all those things and say you have built the entire firmware yourself. Then you will get into those kind of applications. Those are some of the applications where it's mostly regulated applications, right? But in a mass market kind of an applications, right now, we don't have an Indian processor which can compete with any of these. But we are getting there. The interesting point is we are giving this feedback regularly. We are working with them. We want to make some of these products successful in India eventually, right? Like so, hopefully, like sometime next year we will get some of these ICs to be more cost competitive and stuff like that in India.
But the initial question remains, the only USP so far I understood of the Indian ecosystem is that it is Indian. Or is there going to be another additional benefit out of it?
So,
The support also.
see, there are a lot of things actually. So that question goes very deep. So like maybe if I want to highlight like some of the others.
Ask it a little differently. So what I have understood so far is, be it China or Taiwan, any other country, they started step by step. Initially, China was only doing packaging. They never were doing full fabrication. Then they went for these kind of events, type of chips. Gradually, they climbed up the ladder. What I always see a discussion about is India directly doing the SOC or not? So I never see a discussion about doing something simpler, start off rather than keep on aiming something very high.
We have lost the race. We have lost the race. Basically, we have lost the race. Because at this point, we are going to do well and we can't, financially, economically, we can't stand. That's the point.
There's no point in doing ULN kind of IC anymore in India. That is a commodity now. But where some of the opportunities are, if any of you are thinking about something like you want to do something, you can do something in even if you start designing silicon carbide or gallium nitride, right? Like there are a lot of applications using the technology to do something. That is where I was hoping personally, Zoho to set up a plant. It's very unfortunate they killed the project. Because they were focusing on silicon carbide and silicon carbide specifically, which is really important. Like I think that is where, so if you take the global foundry this thing, those technologies have not evolved to an extent as how the processor technology has evolved. So that those process nodes for silicon carbide and gallium nitride is there already. TI has a gallium nitride plant. Silicon carbide also, but it is not as matured as other processes. So that's an entry point for Indian conglomerates who have spare funds, 5,000 crores funds to invest.
So are you saying that India has better chances to directly do a carbide SOC in comparison to a similar product?
I would not say carbide SOC, carbide based semiconductor ICs. So what it means is using silicon carbide, you can do a lot of power devices, right? Like mainly power devices. If you take gallium nitride, you can do a lot of sensors. Gallium nitride opens up a lot of sensor applications.
Wireless also, gallium nitride.
Yeah, for wireless also. Yeah, for wireless, you can do a lot of gas sensing. So yeah, I don't know if I think it's open now. Like yeah, in TI. So I was working for TI before like starting like Lion Circuits, right? So they back then in TI, if you're working on gas sensing based on gallium nitride, it's now online. Like you can go check it out. So there are a lot of sensing applications based on gallium nitride. There are a lot of these kind of applications are very unique and is still nascent. So that's where India can enter and make a mark in the sector. All is if somebody wants to start a competition for TSMC, good luck.
And one more thing is we are losing a lot of dollars importing electronics.
Yeah.
That is very important.
Yeah.
That is a very
After
important.
oil, it's electronics which we are importing. That's very
Yeah. So we have to try and so to your question of whether it's only a brand made in India or is there anything else to it? Definitely there are a lot of things to it. See the ability to if you have the ability to build something here, right? Just imagine what all things you can do in the future, right? So what is the meaning of that? I'll give you a simple example of why we should build PCBs in India. Because semiconductor is far-fetched for me right now, for all of us right now. Because what I believe is like we are not even cracked PCB in India. We are not cracked PCB in India. What are we talking about, right? Like PCB is a smallest version of semiconductor. Like it's almost like PCB. To manufacture PCB, you have to have a lot of process. Like in our plant, we have a lot of process equipments, right? It's a large form process equipment. What we do in semiconductor is miniature version of it to a certain extent. For example, we are able to control 20 micron error in our factory right now. 20 micron, right? If you build a semiconductor, we'll be talking in nanometers, right? So to do this, to be able to crack this and build at scale, give you all boards in 48 hours, right? This is a dream. This is coming true in maybe a couple of months. But since we have not even done that, right? There are a lot of no-nos. It's not like okay, I'll pump in 100 crores, 200 crores. Like tomorrow I'll build a plant. It's not easy as that. So there are a lot of knowledge that we'll have to understand, build, iterate. That knowledge is what we are going to gain if we start doing things in India. That know-how is what we are going to get by doing things in India. So, to a small point of that, because we are able to, through line circuits right now, if I have to speak for PCBs, right? Because we have, customers, we are able to go and say, okay, boss, I'm going to invest more capital, build better, serve our customers better, right? But if I don't have, right, customer base, like where I can say, okay, this is how many customers are there, like for me to do something in India, right? I would not do it, right? Like, so, and another example, if I have to give, is because we are doing this, now we have started to talk to other people to build capital goods. To build capital goods for us, right? Like, so for example, all the machineries in our factory is from China. All the machineries. At least 50% are from China. We tried hard to make the remaining 50% from India. We are using a lot of Indian wet processing machines. It's not up to the quality that we were expecting. But we're still supporting them. We're still using them. So at one day we are thinking, hopefully, like for our next plant, they'll get better. They have understood a lot. They'll give us better machines, right? So now the remaining 50% of the machines, which is like high-end machines, those are the machines that we have to import, right? Why? Because if you go and look at it, like some of them are, it's like if you put like good amount of time, if a team puts a good amount of time, they can crack it. It's not very hard. But however Chinese done this, they also started like this. They were the same, whatever we are now. They were 15 years back. They were doing the same thing. They were doing shitty quality boards. They were doing like very very bad quality boards. They didn't know how to do it. 15 years later, they are doing fantastic. They are top-notch quality boards. We have to look at it and say, okay, how are these guys doing it? Right?
Very low cost.
Very low cost. So they have optimized everything. How are they able to do? They have local suppliers. Local suppliers for everything. You take like we have a flying probe tester. They have a flying probe testing ecosystem. There are 10 manufacturers in 50-kilometer radius who can supply a FPD machine. There are at least like five suppliers for a high-speed CNC drill machine. Right? If like there is no one in India to supply a high-speed CNC drilling machine for PCB industry, right? That machine, if it can do 500 drills per minute. The machine that we have right now can do 500 drills per minute. German machine can do 350 drills per minute. You see like the difference, right? Like Chinese machines were very bad. Chinese technology was very bad. Because so much emphasis was given on manufacturing in China, everything in China. They became so better in everything. Now some of their machines are way better than the German machines.
Example is a ESP cutting, right?
Yeah.
Can I ask a follow-up question?
Yeah.
Yeah, can we
Extending the same.
ask other questions as well related to the topic, because we wanted to understand and keep on just wanted to understand, once we have seen all the parts and components, how can we design a simulation for this? Is it possible? Is it a good idea to design simulation?
No, it's mostly not the simulation. You'll get a EVK. Initially, I was talking, right? So you'll get the SOC based EVK, and they'll have all the pins and peripherals that is needed for that. And then you deploy your application there, test your application. If it works, then you start optimizing the EVK into a product.
So how do we get the EVK of a product?
You contact the manufacturer. So in terms of NXP or TI or any big brands, you'll directly get it from houses like DigiKey, Mouser, Arrow. They'll give you the direct orders. But whereas for chips like this, you have to directly contact them and try to talk and get the EVK kit for it. Yeah.
This they have done that selling this product, right?
Yeah.
3,500.
Yeah, around 3,000 rupees. Yeah.
So what is the volume they manufacture?
This again, one more thing is this particular brand, right? It is rebranded one. Basically, it's not their own manufacturing. OEM is someone, and they'll be manufacturing it in millions. So it'll be at least say close to 5 million. Yeah, that is
One cycle they are doing 5 million.
not necessarily in one cycle. I'm just talking as a whole. Yeah. But it can be more as well. Again, that is why I was talking about the engineering aspect. They put a lot of effort into the engineering, so the final cost of the manufacturing is way lower. So once they hit that scale, that engineering cost becomes substantially low. So whenever you are scaling, you have to think in that way. So either if your product customer is say only 10,000, then it doesn't make sense putting so much engineering cost. Yeah. So you make as whatever is readily available, try to put everything together and start selling it.
So what is the best way to reverse engineer this?
Best way to reverse engineer.
Yeah, like we want to make, so we have.
You want to make IP camera basically. So first you list down the features from this particular set. If your feature exactly matches it, you don't even have to reverse engineer. Just get the same SOC. You talk to the manufacturer, he'll give you all the details how to set up everything. Then you do the component selection for, like I was showing you the flash memory, right? Maybe that particular brand might be cheaper for them. Maybe for us, there's a different brand which is cheaper. So we can put that in place. And the same thing for the camera sensor as well. Let's say they went with a 3 megapixel. I'm not sure what the sensor is. Let's say it's a Sony, and you can put some other like a OmniVision. So it is cheaper than the Sony version, something like that.
From the flash memory contains Linux OS.
Yeah. So you can't pull that out.
Is it possible?
No. You can't pull that out. But there are some attacks that you can basically do and try to get a root access to that and try to fiddle around. But again, it's a different process. Yeah.
See, another way to get, like, if you want to build IP cameras. See, IP cameras are very hot right now in India. There are a lot of regulations that are hot.
I'll get the NXP.
Yeah, a lot of regulations where government.
I'm so sorry.
Government introduce. அவன் கொடுத்து போட அவன் டிஸ்டர்ப் பண்ணுறா அவன் கூட கொடு நான் உனக்கு தேங்க்யூ உனக்கு வர வெயிட் பண்ணு சரி சாப்பிட்டு போட போட்டு வைங்க அப்லோட் ஆகலாம் இதெல்லாம் வச்சிருக்கணும் So there is, I think the October builds you can get started with a lot of libraries, lot of open source libraries are there. So that is one easy way to start. This is a very old version of one of our boards for camera solution. Right? This is the main board. This is a base board for I think this is a SOM board. Right? Like if you see this SOM board.
So you would have seen the CM4 board, right? Something like
CM4 compute module, something like that. But this can I remove it?
Yeah, you can.
So this is like baseboard. This is the SOM board. It's fully manufactured Reliance circuits. Like we have all the technology to manufacture these kind of boards. So if you see this has what is the NXP?
IMX 93. This is
the IMX 93. With Micron.
DRAM, Micron DRAM,
Micron,
and
right?
from Kioxia we have the eMMC, flash memory.
So primarily these three components, right, and then the entire SOM and the PMIC, right? Like that's the base, the slide which Srinivas showed initially, the same. So this is a fully Indian version of.
Selling this online?
We are not selling this online yet, so we are going to be launching this, but we are refining a lot of things to optimize the costs. So that what is the advantage of this? So anybody who wants to develop camera-based application, anybody who wants to develop display, high-speed displays, multimedia, those kind of things, you will be able to use this. This also has an NPU, right? If you want to run a lot of edge inferences on this, you can run it. We have a lot of demos where we have run edge inferences on this directly. You can run a lot of edge inferences, like it supports a lot of models.
And they're also
readily available models.
And also it can be used for audio application also. As you told, for a display camera, there is like 4 different microphones that you can connect to that particular SoC, and you can do like AC, beamforming. So if you want to build like something like Alexa, it should be very easy and out of the box.
Yeah. So mainly the thing is, this is a NXP based. So NXP is pretty neutral, like in terms of like on the geopolitics that is happening. But a similar board we also have for Rocket, right? And Rocket maybe. So
Rocket is in Taiwan, right?
No.
Rocket, which variant?
What is the fully ready board, which is cost optimized. You just have to use it and say this is what I'm using. So we say that like we'll manufacture that stack. So the development becomes fast.
For example, we are using RK3288. So compared to that board, 2 GT16
Yeah, this is actually it'll be a little cheaper. RK3576 is less expensive than RK3588, but it has 6 stops. Yeah, little less, but it uses the same 6 stops for NPU. That is the same thing in RK. So performance difference is very less. But I know there is a ARM Cortex. There is a little changes there, but both of the software should be compatible with each other.
What is the application if you can share with us?
So I'm from Boston, sir. You might have seen in Rameshwaram.
Oh, yeah.
So that's us.
I know.
So we have been manufacturing all-in-one kiosk displays from last 6 years in Bangalore. That is the
What is the product?
Go sensor.
Go sir.
Kiosk.
You know, you have
Take the tea, coffee.
you can select the food items and
Like you see in McDonald's.
Similar to that, we are building it for Indian market.
yeah.
So,
You are having the Rameshwaram cafe and
Veena stores.
so now we are supplying all
We
over
love
India.
your product. Like, Veena stores, there was so much queue. Like
gives the time.
it's like this product has sold a lot.
This is only for F&B or
No, we are doing it for retail,
textiles.
endless signs, scan and learn, similar to Decathlon applications. So we are doing it.
How much is one unit?
We give it in a subscription model, the whole setup. We don't sell it.
Anybody else wants to share like what you are building? Maybe I know you want to build something. Like you want to share like what you are building. We can maybe all discuss about it.
So I'm from Lucid Technology. So we are launching like our AR glasses. So it's basically currently not AR, but it is a pocket TV. So you might have heard about Rocket or XDR.
Mm.
Right?
Yeah.
So they have these glasses. You can wear those glasses and connect to your phone or laptop, and you will see a 180 inches of screen. So we are using Sony LED. We have our own custom PCB, but some of the components are mainly sourced from China. We have started pre-orders. We are going into launching in 2 months.
Okay. Nice. Where are the companies based in Bangalore?
So it's registered in Ghaziabad, Uttar Pradesh, but the tech team is in Bangalore.
So what's the SoC file? Like what you are using?
We have sourced compute unit from Khadas. You have heard about Khadas? Khadas is also a Chinese manufacturer. They make their boards are like similar to Apple Mac Mini versions. So
Okay.
they have that GPU NPU octa-core processor. It's a small size. But mainly we are struggling with the microcontroller part aspect of it because that is completely sourced from China. All the components.
Is having problem sourcing the component or
No, getting an understanding and customizing, optimizing. Yeah.
Are you getting like Horizon OS or something like that?
No, not Horizon OS. So basically, there is no OS in the glass itself. You have to connect it to your phone.
It's just a beaming display.
Yeah, so basically the Horizon OS requires a CPU. So in glass there is no CPU or processing happening. You don't need a power supply. Your phone will power the glass.
You have to wire it to your phone.
Yeah, currently it's wired. We have a wireless version in lab.
But will it be heavy or wireless?
No, it weighs around 75 to 80 grams.
Okay.
The entire unit. You can check it out. Luxit.tech. It's our website.
Yeah.
Sanjay, why don't you also join? I think we are now almost 3 o'clock.
We'll just finish it.
Food and like
Food,
that
yeah.
setup,
So we'll
yeah.
take a break.
Networking and then discuss.
Okay, is it? We'll take it offline.
Yes.
Okay. So, but why don't you guys come over here? So
Like it took more time.
yeah, I think this took more time.
No, it's okay.
So this is Purvendra, Sanjay. They're Brandworks. Why don't you just give?
Yeah, I think when we started out in the recap, I kind of gave a quick introduction, but what essentially Brandworks does is we do end-to-end product development, right from ideation, sketching, understanding what product needs to go in the market, what your customers really want, getting that down to proper sketches, understanding what should be the specifications, like here you understood, right? Like from what feature to what spec to what component, down to how much power it needs, including all the components, what sort of enclosure it needs, how it should be assembled, what sort of plastics need to go. If you're using something like a wearable, what about the biocompatibility? Will it give irritations? What sort of certifications? Does it need ROHSC? Will it blow up? Does it need any other certification? So all of these things put together, then the packaging, transportation. If you have to ship it to US, will it break when it gets shipped? What sort of testing is passed? So the end-to-end, right from ideation to production and delivery is what we kind of come into, and we are end-to-end systems development company for all sorts of products, right? We've done VR glasses for some of the companies, we've done huge machines which do like PCB assembly, which do special purpose machines, all the way from small handheld tech products to large machines. These are capacity, and that's what in this entire session we're trying to discuss different ways of approaching product development. It's not just one particular angle; you have to kind of approach it in many different angles. So that's what the whole session was. So yeah, hope you guys like the session, and hope you guys get to go through more details. I think we'll further share QR codes on previous sessions. Feel free to go through all of them. Going forward, I think we are planning to open up like a Discord channel. I don't know how many of you guys are on Discord, but we'll definitely try to put up a Discord channel where we can share, hash out stuff. We'll keep you posted on the next set of sessions that come up, and the next one will probably be a different series, and it will be probably more, it'll be oriented towards something else rather than just a product. Maybe some, we'll keep you posted on what's going to come up next.
So can you share a bit about your engagement model? Is it like a duration based or scope based, and what are the broad commercials?
Usually they are very flexible. It's scope based most of the time, but then depends on the size of the company, size of the project. Some companies do a retainer based engagement. If the project goes for let's say a year and a half, there's a monthly retainer in place. If the project is let's say relevantly smaller, let's say 3 or 6 months, it's more or less like lump sum. This is the scope of work, do this, and then we go on to the next
Can
phase.
somebody do this as a side hustle with you? Let's say somebody on a regular job. They can
A lot of companies do that. A lot of them. It's like we're making a machine that brews beer. Both of those founders work at Google and APN Web Advisor. So they are doing their full-time job already. We do the rest of the things for them, and whenever they get the chance, we can.
So except for the financial modeling part of it, you kind of put the entire technical.
Yes. It's more like, for example, for some founders, they really need us to take care of everything, but for some other people, they are either expert in app development, they want us to do the hardware, they're expert in, let's say, electronics, they want us to do mechanical work, they are expert in mechanical design, they want us to do the electronics. It's always a mix and match of something, right? It's, I would say, maybe like 10 to 15% come to us where they say you take care of everything. 85% is like we take care of one thing, you take care of 10 other things.
And you also mentioned certifications for different countries. You cover that?
Yeah, usually if you cover like FCCC, pretty much works everywhere else. You don't have to take a head over anything else. When it gets into medical, right, that's where the challenge is. In the medical space, it's very, very challenging. FDA is the most difficult. If you clear FDA, kind of works everywhere else. For India, it's CDSCO. We are currently in the process. 3 different startups are working with us for like the 3 different products and trying to get that through clinical trials, and because if specifically if there's something that works with injecting into the patient, then it's very high level of classification.
So all other domains, it's fairly one or two certifications that you have confidence in.
Yeah. Whatever is needed for whatever is needed, and then it's up to you to choose.
What about the automotive and the aerospace? Do you put that on?
Yeah, we did work with a company for the AIA certification and homologation for a EV bike, but there are a lot of ways.
What type of it is like cargo or personal?
Cargo. Three-wheeler cargo. Yeah.
But not like an auto. But now recently you
Trike, more like a trike.
Yeah. The Zomato has a delivery system. Yeah, something like that.
Box and then insulated box so it can maintain
driverless three-wheeler stuff.
with driver on. With driver. Autonomous is too difficult to say. I mean, startups are going to try take a long time trying to crack autonomous.
From the electric mobility,
Sorry?
from the electric mobility space.
Which company?
I was with Sun Mobility.
Sun Mobility.
Okay.
So the next wave in that space is autonomous.
Yeah.
So there are many companies doing work in autonomous, like mining, ports, internal campus, etc.
Yeah, correct. So for that, like, for some of those, like, we recently
Minus zero.
Minus zero.
But we come across on the other spectrum where we developed a EV vehicle for a company, particular company. They wanted a particular price bracket to be achieved. The way that we developed and the way the product went about, they said, okay, now the unit economics doesn't make sense. I might as well just put the guy in a truck and send it to them.
So we spent about 6 months, built the bike at the exact cost that they wanted, built the bike at the exact specific range, speed, everything done. They did all the unit math and they said the driver salary is what we're not able to bring down. No matter even if you give us the bike free of cost and it runs forever with no charge, driver salary won't match. So really need to use a truck for this.
You have capabilities of everything except manufacturing.
So manufacturing, let's say for example, for PCB assembly, everything we partner with Lancet, right? So Lancet does all of the manufacturing for us. They do the box builds for us. But whereas it comes to other stages of manufacturing, metal, plastic, we have our own
Enclosures.
tools for it. Enclosures, right? For example, a lot of parts in this are injection molded, right? So getting down to the plastics, which connectors to put together, how to assemble this. Is this a press fit? Is this a rotating fit? Is this whatever? So all of these things we put together, and then all the molded parts and let's say the enclosures come to and they do the box build and ship it to the manufacturer.
Can you talk about one of your products which has been a commercial success and like in general, what was your contribution to make it a commercial success?
One of the best products that we have done, and it's been the product that we started our journey as well, was an EV charger. So there's a company called Bright Blue. They started off in Bangalore, now sitting in Pune. So they started with a basic AC EV charger, and they started using Chinese-made existing casings, just as common square casings, and they shipped around, I would guess, close to around 25K units. But then after that, they needed to get their own mold. The customer started demanding, like, I need a beautiful looking EV charger now. People have seen Aether charger, now they're comparing with ours. We need it to look a little more better. So we work with them on a complete mold design, complete versatile design. So that charger right now is going international as well. After we finish our CE certification and everything, the first installation was in Netherlands, Europe, and many other places it's getting installed. And they are working with some entity with Germany for this to be shipped over there as well. So there's really one of the
even that journey was interesting because the fourth iteration of design is what is getting sold right now. The first iteration never made it out of the workshop. Okay.
I think
you also manufactured the first 20,000 words.
They were doing it for a company called Drive. They got acquired. So they're still doing it. Like, through their startup to acquisition beyond that.
Only supported all the way till first 20,000 words also you manufactured. And then they.
Is it firmware also?
Sorry?
Yeah.
We do firmware also. So for example, Bright Blue, right? Their expertise is in firmware and app. Right? So they wrote the OCPP protocols, they wrote the entire OTAs, app protocols, charge point operator, integration, everything. So what happens is the first design never made it out of the workshop, the second design kind of they showed it to investors, the third design they started manufacturing and assembling, the fourth design. They sold the fourth design, I would say maybe like 5,000 units in India without any certification. When Europe said I really cannot take a product without a CE, only then that went to CE, got here in Kenya it got certified, then everything started selling. So it took probably like 8 months to get the CE certification done, but until then a lot of chargers were sold already. And the fact is that only when you really need it, you may want to go for charger certification. Right? You really don't have to. It's probably pointless to do everything first and then go out, unless it really needs. Like medical, you really can't do anything. You can't operate until certification is done. But EV charging, okay, you can do. Not a problem.
So probably to put our skill set, if I take an example of the beer brewing machine, the customer is actually a beer expert. So he went to Belgium and he's done all the courses. So end of the day, all you have to give it to him is beer in the glass, and he'll say, okay, this beer is perfect. I can go ahead and start selling this machine. So the machine dimensions, the machine interaction, the app design, firmware, everything to do with the machine is something that we take care of. The end of the day, the beer is good or not is the only thing the customer will take care of. So our capabilities lies from all the way from there.
Is it turnkey?
Yeah, basically turnkey.
Yeah, fantastic. So like something similar snacks.
Yes.
We'll get some snacks and
We'll take a picture, yeah.
Okay.
We can assemble this side?
We'll all stand here.
Yeah. If all of us can come this way.
We'll just move the tables. Just move little front. I think it should be okay. हाँ. Yeah,
After everything wraps up, can you
yeah,
give
yeah,
me a
sure.
5 minute of time?
Yeah, sure, no problem.
My name is Chandan, by the way.
Okay, it's on the screen. 2 minutes. I'll join back. That works.